Hi, welcome to a quick review of factoring techniques that you learned in Algebra 2. It's very important to be very proficient in your factoring because when we get to the trig portion of this course, we'll be factoring with things like sine, cosine, and tangent, those kind of things. So real important that you can do it with x's so that you can then apply those skills to your trig functions. So in Algebra 1 and Algebra 2, these are basic methods that you should have learned. Greatest common factor means you're dividing out the largest factor that the terms have in common. Difference of two squares, sum or difference of two cubes. Perfect square trinomial, trinomial with a leading coefficient of 1. So that would be something like x squared plus 2x plus 4. And then trinomial with a leading coefficient other than 1. So that would be something like 2x squared plus 4x plus 16. And then factor by grouping, where you have 4 more terms and then you're breaking them into smaller groups and using that GCF technique to divide out common factors. So basically, here's just kind of a graphic piece to help you organize when you can do what. If you have at the top in big green there, it says factor out the largest common term. That means factor out the GCF before you do any of these other methods. Then with what's left, you have, if it's a binomial, you could use your pattern methods of difference of squares, sum or difference of cubes. If it's a trinomial, then you could use guess and check, which a lot of people do because they're really good at their multiplication facts, or you could do it with grouping. Some people use a cab method, which is like a cab chart, and then a box method. So the trinomials, there's lots of different ways, and you just need to make sure you are very proficient at one, and you can do it well, and you can do it fast. And then finally, if it's 4 more terms, then typically we do that by grouping. Some people take their groups and put them into little boxes, which is fine, but again, anytime you use that box method, you need to be quick and proficient at it and not be slow. So there are some that we learned and some people learned in patterns. Difference of two squares, both terms are perfect squares connected with a minus sign. That factors into a minus b and a plus b. Sum and difference of two cubes means both terms are cubes. Something times itself 3 times, and it can either be connected with a plus or a minus. And so these are the patterns for that. If you're factoring a perfect square trinomial, that means your trinomial will factor into 2 of the exact same binomial. There is a pattern for that, or you can simply just do the general trinomial factoring and you'll end up with the perfect squares at the end. So real quickly, kind of refreshing your memory about greatest common factor, that means you've got terms, and it could be 2 terms, 3 terms, 4 terms, but they all have something in common. So for just a refresher here, 3x to the 5th means 3xxxxx, and negative 15x squared would be negative 3 times 5 times x times x. So you can clearly see that there's a factor of 3 in each term. There are 2 x's in each term that are similar. We take those out, and that's called the GCF. And so what we're really doing is dividing each of those by 3x squared. And what happens, and this is just breaking it down as a refresher, is that you're kind of just eliminating that common factor, and then the piece that's left here and this 5 over here would be what's going to go into its own binomial, and then what the GCF would be out in front. Always check for common patterns at the end and make sure that you don't have a problem that will keep factoring even after you've taken the GCF out. So in this case, this is another example of GCF, but there is a negative number, a negative leading term, and so we have to take that into consideration. So then when we look at the factorization, we can see we have a negative 4 times 4, which is going to give me the negative 16. And remember that 12 is a positive 12. That means you could have a factor of negative 3 times negative 4. Don't forget about that sign possibility there. So then when you look to see what's common in both of them, you can see that you're going to have the negative 4 in the x, and everything else is left inside. So we get common factor, we get the remainders, and when we put it all together, we get a factorization that looks like that. 4x minus 3 is just a linear term, so there is no other difference of squares, sum or difference of cubes that you could break that down, and it doesn't have any more of a GCF because we just took that out. So greatest common factor, factoring, in this case it is a trinomial, but notice that 6, 24, and 15 all have common factor of 3. So we can take that 3 out and put everything in the binomial, and then we would check that remaining binomial because it is a trinomial to see if it would factor more. So 2 times 5 is 10. There are no factors of 10 that add up to be 8, so we know that we're finished. Difference of two squares, we have a binomial pattern here, two terms. They have to both be perfect squares, so 9 is 3 times 3, x squared is x times x, and 16 is 4 times 4. Has to have a minus in the middle. There is no sum of two squares, there is only a difference of two squares. So then that's going to break down into two identical binomials. The difference is just that sign. So one is a plus and one is a minus. And you check both of those. They're both linear, which means they're not going to divide out anymore, so you know that you are finished and you can move on. Here's another difference of two squares. Remember that when you have x to the fourth, that's a power higher than 2. So when you factor that down, you're thinking what plus itself gives you 4. So that means it's going to break into two binomials that look like this. But remember we said we needed to check those patterns? Well, if you look at that first one, that one is a difference of two squares because x squared is x times x, 1 is 1 times 1, and there's a minus in between. So that piece still breaks down further, and you still have to keep x squared plus 1. Don't drop any factors, and if you take out a GCF, remember that GCF does have to be in your final factorization. If the leading coefficient is 1, in this case it is because that's 1x squared, then I look at the factors of 10, and I want to find factors of 10 that will add up to be -7. So I can look at those in the table. I know 1 times 10 is 10, I know -1 times -10 is 10, I know 2 times 5 is 10, and I know -2 times -5 is 10. So then I add those together. 1 plus 10 is 11, -1 plus -10 is -11, 2 plus 5 is 7, and -2 minus 5 is -7. And that would be the one that is going to give me that middle term at the top of -7x. So if I'm doing that, then I use that -2 and that -5. That goes at the back of each binomial, and there's an x in the front because x times x has to give you this x squared right here. When your leading coefficient isn't 1, then you're going to use grouping method, box method, cab method. There's a lot of them out there. Just make sure you can do what you do well. The first thing is the same on all of those factoring methods, and that is you take the a value, which is in front of d squared, and the c value, which is 18, and you multiply those two things together, and that gives me 36. Well, once I have the 36, then I need to find two integers whose product is 36 and who adds up to be 15. And we rewrite the middle term with that same variable, and we can proceed that way. Keep in mind, once you get to right here, that's where all the trinomial methods where a is not 1 are the same. Up to that point, you do that for any of them. Then what you do with those two factors that you find is what happens next. So when I add those together, I can see that 3 times 12 is 36 and 3 plus 12 is 15. So the reason I went ahead and gave you an example on grouping, because that seems to be one of the more common methods that I see coming up from Algebra 2, which is perfectly fine. So I take that 15D out and I replace it with 12D and 3D. It could be in any order. You put those in order that's going to help you factor out in the next step. And so then I group each of the two factors together, take out the GCF for each one, and then I take out the D plus 6 from both of these. That's the common factor, and then the GCFs that you pull out go in the back, or it's multiplicative, so you could put the 2D plus 3 first and then the D plus 6. It doesn't matter the order. And then you check each one to make sure that it doesn't factor anymore. There's no patterns. They're both linear, so I know I'm good to go. All right. Here is an example of a trinomial with the box method. So this is the first term, this is the last term, then you put those two that we found a minute ago that made 15 on the diagonal. That comes from the cab chart. Don't forget to put that letter with it. And then a whole lot of factoring. So you factor, take the GCF out the first column, the GCF out of the second column, the GCF out of the first row, and the GCF out of the third row. And so as you can see, the answer is the same that we just found with the other method. But I think these are probably the two most common ones that I see, so I wanted to work through those. If you do a different trinomial method and it works for you, that's fine, but you really got to know how to do those trinomials. Perfect square trinomial, you can still get there if you just do general trinomial factoring, but it is handy to know. And if you can recognize it, then it makes it easy. So my A term was 121, and that's 11 times 11. My last term was m squared, so that's m times m. And so what I do is I multiply, or I look at these two together, and I get 22m, which is 2 times the 11. And that means it's going to factor into this AB pattern, which is going to give me two binomials that are exactly the same, which means that it's squared, or that binomial squared. But like I said, if you don't remember this pattern, it's not a big deal. You can definitely get there with any of your trinomial factoring. It's just one of those handy ones to know. All right, so factoring by grouping, you have 4 terms, so 4 or more. When you do it by grouping, you do just what the name says. You put it into groups. So I'm going to put it into 2 groups. That's 2 groups of 2. And then I'm going to take out the GCF out of each group. And then you can see again, like we had in the trinomial example, we have x plus 5 in each term. So the common term becomes one of the factors, and the GCF that you pulled out becomes the other. And then I check my 2 patterns to make sure they won't factor down any further. And x squared minus 3 is something bigger than linear, but it doesn't have anything that's going to let me break that down any further. So that becomes your finished answer. So that's grouping. Here's another example of grouping 4 more terms. So I group the first 2, and I group the last 2, and I take out the GCF out of each. And you can see that I have that common x minus 3 factor in both. So that becomes one factor, and the GCFs become the other. But here's an example of I'm not finished, but wait, there's more, because x squared minus 16 is the difference of squares, because x squared is a perfect square, 16 is a perfect square, and it's connected by a minus. So we're not finished. We have to break that down. So x squared minus 16 is going to factor into x plus 4, x minus 4, and don't forget the x minus 3. Remember, any factor you have has to make it all the way down to the final answer, even if it happened at the beginning of the factoring process. So we have no patterns left, so we have nothing left to factor. And you can see now all 3 of those factors are linear, which is a pretty good indicator that it's not going to break down any further. And so we know we're finished. All right, so here's kind of a combination one. So we can do a couple of things. First, hopefully that you notice all of those have a base of 6. So the first thing I can do is take out a GCF, and I can pull that GCF of C out. And there's the 4 terms that I'm left with. Well, then I take the 4 terms and I break them into 2 groups of 2 and take the GCF out. So this C is from the original GCF. This is from the factor by grouping. But remember that we need to check our patterns. And so when we factor that out, hopefully you see that that's a difference of squares, because c squared is c times c, 1 is 1 times 1, and it's connected by a minus. That means that's going to break down further. So when I break that down into c minus 1, c plus 1, that's only part of my answer, because I still had a c plus 1 from here, and I had a c from here. So it takes all of that to be my final answer, because if I didn't have all of that, I couldn't multiply that back together and get back to the original problem that I started with. So if I leave off any of those factors along the way, like the c at the beginning or the c plus 1 that develops along the way, then I wouldn't get the same 4-term polynomial that I started with. So that's very important. Never leave out those factors when you're factoring. And since there's no patterns left there, we know we've finished the factoring process. So I hope this has kind of helped with a bit of a refresher on your factoring. There are, lots of examples out there. You can go to Khan Academy. You can go to purplemath.com. All of those have additional help videos for you if you need a little bit of additional help on factoring. But I can't emphasize enough, you really need to be good and strong and proficient at factoring, so that when we get to all of the trigonometry stuff that we'll be working on this year, you will have a easy time at it.